Guys are keeping well. Today we're going to be doing term 3 work, and then we're starting with grade 8 and 9 geometry of straight line. This applies both to grade 8 and grade 9s. Okay, if you were not so focused last year on your work, this is you. Okay, so when you're doing geometry of straight lines, what are we talking about? We're talking about straight lines. Okay, this is basically we're going to be dealing with straight lines. Okay, and then the first thing that you guys need to know, I'm gonna be very to the point. I'm just gonna get straight to the point. All right. So the first thing that you guys need to know is this law of straight lines. Okay, this is very important. Do not forget this. Is that you must be able to say it with your mouth. It says that sum of angles on a straight line, right? These must add up to 180 degrees. Okay, so sum of angles on a straight line must add up to 180 degrees. What do we mean? We mean if we are ever given a straight line, for example, if you look at this diagram here, right, all the angles on the straight line must always add up to what? 180 degrees. What does that mean? It means angle 1 here plus angle 2 must add up to what? 180 degrees. It means they must give, when we add them together, they must give us what? 180 degrees. Okay, and then when you're doing these things here, you always have to give a reason. Okay, our reason is what? Angles on a what? Straight line. So this is the shortened form of sum of angles on a straight line add up to 180. So when you tell us that angles on a straight line, we already know what you are saying. All right, so at moments, right, there's not only two angles, but there are multiple angles on the straight line. For example, if you look at B here, right, we have angle 3 plus angle 4 and angle 5. When we add these 1, 2, 3, we must always get as well what? 180 degrees, because angles on a straight line add up to what? 280 degrees. Okay, with that being said, let's just prove this, right, in just a few seconds or minutes. Okay, so I'm going to use a protractor, right, and then we're going to count, right. You see this protractor here, right, every small stroke, these ones here, if you look at these strokes here, let me change to a pen, these ones here, right, it's like 5 degrees. So this is 30, right, so this is going to 35, 40, 45, then we have 60, and then we have 90 here, then 90, 95, and then with 95, then we at 100. Okay, so it means this first angle here, angle 2, right, we are manually calculating it, right, is what? Is 100 degrees. All right, and then when we now take back the protractor, right, let's take it back and we put it right there. Okay, and then you can count backwards, since you know that this is going to be 5, 10, 15, 20, 25, 30. All right, and then from 30, you know this is going to be 60. All right, your protectors work much better than mine. Okay, and then if this is going to be 60, right, then 65, 70, 75, 80. So it means, what does that mean? It means now that angle 1 is what? Is 80 degrees, and then when you add 180, you get what? 180 degrees. Therefore proving that really angles on a straight line add up to what? 180 degrees. So we are proving that manually. So all right, therefore I'm going to do this one here of 3, 4, 5. Okay, but it's still gonna give us what? 180. Therefore we now know that angles on a straight line add up to what? 180 degrees. Okay, now the other important thing that you need to know is just this two, can I say three terminology. Okay, is that number one, supplementary adjacent, and what we call supplementary adjacent angles, right? So when we say that angles are supplementary, these are just two angles next to each other that add up to 180 degrees. Okay, and then when we're talking about adjacent angles, we're talking about angles that are next to each other, but they share a what? A vertex, which is a corner, and a what? And a common side. So adjacent angles share what? A vertex and what? And a common side. Okay, so usually when angles are placed like this, we say that they are supplementary adjacent angles, because for example 1 and 2, as we proved there, they add up to 180, right? But they also what? Share a vertex and a common side, so they are what? Supplementary adjacent angles. All right, without wasting any time, let us go and do examples, and let me show you how we use that law to find unknown angles. So we are going to be solving for x and solving for unknowns using that what? That law, which says angles on a straight line add up to 180 degrees. So if you look right here, right, if They say calculate the size of A, okay? You realize that this is a straight line. And then the law says what? Angles on a straight line add up to 108. So it means when you add 63 degrees plus A, you must get 180 degrees. And then you must always give a reason. Our reason is what? Is angles on a straight line, people. All right. Therefore, remember, algebra is coming back. Solving for x is coming back. Solving for unknowns is coming back. Okay. Then we need to solve for A. If you remember properly, how do we solve for A? We want A to be left alone. So we take 63 to the other side. Okay. 63 was positive. When it goes on the other side of the equal sign, it becomes negative. Therefore, A is equals to 180 minus 63 degrees. These are all degrees, guys. And therefore, you punch this into your calculator. You say 180 minus 63. You get 117 degrees. Okay, good. Let's do the next one. So on the next one, you can pause this video and try it by yourself. Okay, remember you're practicing here. All right, you pause it, then you do it, then I'll still do it. Okay, then you now notice that number 2 say calculate the value of what of x. You realize that now we have more than 2 angles. Okay, but the law still remains. The law says as long as it's a straight line. Okay, as long as it's a what? It's a straight line, and there is our straight line there. All the angles must what? Must add up to 180. Therefore, we know that x plus 29 plus 90 degrees must give us what? 180 degrees. And then you also give your reason angles on a straight line. Okay, remember this is the shortened form, okay, of the reason angles on a straight line. When you're doing geometry, always give reasons. Okay, always give a reason to why are you saying x plus 29 plus 90 is equals to 180 degrees. All right, now therefore it's just a matter of solving for x. Then you can say 29 plus 90, right? Then you get 119. Therefore x plus 119 is equals to 180. And then x, we take the 119 to the other side. It is positive, it becomes negative. We have 180 minus 119. Where you punch this into your calculator, please always confirm your answers. Okay, so we have 180 minus 119, and then we have what? X is equals to what? 61 degrees. We're done. Now let's go to the next example. All right, this is the last example that we're going to do. Remember, this is still a what? This is still a what? A straight line, even though it's what? It's slanting a bit. Okay, this is still a straight line. Therefore, now we have what? 2y plus 48 plus 52 is equals to 180 degrees. Therefore, this is angles on a what? On a straight line. Okay, therefore this is, you could also do it like this. 2y is equals to 180. You take the 48 and the 52 to the other side, okay, without adding them. So it's going to be minus 48. This is just a lazy style, okay. And then you have 2y is equals to, then you punch it. We have 180 subtract 48 minus 52, okay. Then this is going to be what? This gives us basically 80 degrees, all right. And then remember your algebra. You have 2y. We're looking for, they say solve for y, not for 2y. Okay, therefore you need to divide by what? By 2 on that side. What you do on the left, you do on the right. Okay, therefore y is equals to what? 40 degrees. And then you are done, guys. Let's meet on the next one when we are battling with when we're dealing with now vertically opposite angles.